Thanks for staying this late for the last presentation before the closing remarks. My name is Manuel Rodriguez. I work at Red Hat in the Telco Partners CI team. And I also like to thank for all the contributions and the presentations I've seen. I belong to a team that starts to get familiar with DPDK. And today we are going to talk about an implementation that we have performed. It's basically automation around DPDK that we use with some of our partners. And also I would like to thank these two engineers. Saravanan, he initially started the main component called Example-cnf, and we are going to talk about this. And Ramon, he has been leading the efforts of this project, and it's thanks to him that I'm here presenting today. And I would like to, before starting, just leave it clear what we do and the reason of this presentation. So I work in a team where we test CNFs for telcos, multiple partners, and we use a platform of Kubernetes, in this case OpenShift. We want to make sure that CNFs do not break OpenShift or Kubernetes and the other way around. So we have to build automation in our CI to test from end to end the deployment of the platform, operators, configuration, and then make sure that a CNF can work. But we don't want to use a specific vendor CNF. We want to build something, and that's where we started to work on something based on test PMD and TRex that leverage DPDK. And because it's very complex, that's why we have to build automation from start to finish. We most of the time use bare metal servers that we bootstrap them from scratch, and there is probably like between hundreds of tasks that do the automation all the way to get to the point where we do a CNF test. We do not perform any tests. Like our test is very simple. We just send packages, generate packets, and forward the packets. And we don't test performance if there is an improvement. We are not there yet, but we hope we will get there at some point. The presentation is just, I will start with an introduction of the base components for everybody, just as a reminder, then a quick demo, and we'll finalize with some conclusions. Okay, the first component, as I said, is we deploy clusters of Kubernetes. And the main components of Kubernetes, you probably are aware, are multiple components that provide tolerance and scalability on containers. We deploy these on physical servers, and we use OpenShift in our case at Red Hat. Another component, a very important component in Kubernetes, is operators. We use them to automate and configure certain aspects of the servers, like the SR-IOV operator, and our implementation of Example-cnf is based on operators as well, because it allows us to do the reconciliation that the configuration that we want is already applied, and if it's not, then it needs to be reapplied. The main component of our pipeline is called, or this project is an open source project. We release it, it's open for everybody to contribute. Example-cnf, which at the end is just images of test PMD and TRex to validate, to exercise this packet generation and packet forwarding. The requisites for our deployments are at least 3 physical nodes, and we call them workers because that's where we are going to deploy the CNFs. And we need 3 because we are going to perform a draining or a node reboot test. And usually we have 2 nodes, where in one node is running test PMD and in another TRex. But when we do a powered reboot or a draining, we want to make sure that there is a node available to take the load. And we use also an operator called SR-IOV that will allow us to use the physical NICs and create the virtual functions, etc. And finally, we perform also certain configurations for CPU isolation with a performance profile dedicated for these nodes. Just as a recap, the example CNF that we're going to see, these are the main implementations. Well, we leverage a lot of technologies. As you can see, it goes from operator SDK, how we build the operators, and then we use Red Hat UVI image base to build our images, and then we push them to que.io. These are the images that are going to contain TRex and test PMD. Of course, we use something to automate, and in this case is Ansible. And the kind of the base platform for us is Kubernetes that will allow us to have all the components to deploy and scale and monitor our workloads. Okay, so in the next slide now we are going to talk a little bit about Example-cnf operator. As I mentioned, the operators, we use OLM to build them, and we have 3 operators. We call them TRex operator, and it's the one that contains TRex. Well, test PMD and the CNF MAC operator. That's kind of the one that is new because it takes the information from one to pass it to the other. But at the end, all of them have this cycle of what a sample operator is, which is we have a custom resource definition that what the operator should do, and there is a reconciliation loop that takes care that that implementation is in place. Let's see a quick demo. It's going to guide you through what is exactly that part of the operator. Here, we are going to go to a namespace where we install our operators. And then we list the CRDs, the custom resource definitions. There is one per operator. If we look at the custom resource, we are going to see that we are expecting certain information, MAC addresses, a runtime class, which is the performance profile for Kubernetes. And this is just what the custom resource is expecting. Now, when that translates into pods, when the operator deploys these pods in a deployment, we can see that the pod is actually the same as the definition, but now we see values of the networks, the MAC addresses, all the information that we need for our test to work. And the performance profile, the images that is going to use this pod. So that's just to clarify a little bit how the operator will translate that into pods. And in the next slides, what we're going to do is we're going to see more in details and the scenario where we are going to test. Sorry. This is just the workflow of the operators. The first thing, how we do this is everything starts with a change. Let's say we want to use a new version of the UVI image or the OLM operator to build our containers. So everything starts with a change that it goes to either, we build a catalog to pull that image. Once that image is available in Que, if we have direct access to pull that image, it will be pulled from Que. If no, we will get that image into a registry. But the part below in that workflow is how the operator is going to start from a custom resource, and then is going to create a pod that is going to do something. In this case, we start with test PMD that creates the custom resource, and then it's going to create the pod, and then we create the same thing, but for the CNF MAC operator, that's going to be responsible of getting the MAC addresses and other network information for test PMD. Then we start a TRex container. Well, the CR starts a pod, and what we call a job will trigger the test, the packet generation test. And at the end, we're just going to collect the logs to understand if the packet generation, the packet forwarding was successful, if there was a packet loss, etc. As I said, we rely a lot on automation, and this role is available, is open source is available. It's called Example-cnf deploy. And it allows to deploy examples CNF, but it also allows other things related to certification programs for Helm charts, operators, and containers. We're not talking about that today, but feel free to look at that online. You'll see there is what we request most of our vendors to comply for a container or an operator or a Helm chart to say this is, it follows the best practices. And in the next slide, we're going to see a demo, but just before the demo, the idea of the demo is we're going to deploy test PMD and TRex. Then we're going to launch a test while we are draining a node, one of the workers in Kubernetes. And we're going to make sure that Kubernetes does the tolerance and redeploys a new pod in a different worker because there is anti-affinity. And we're going to measure the downtime and packet loss at the end. So let's see the demo, and I will guide you through. In the left, in the top left, there is a test PMD pod, and in the top right, there is a TRex pod. In the bottom left, there is this is the command line where we are listing the pods, and in the other part where we are going to execute the job. As you can see in the top right, we are showing the statistics of test PMD and TRex, but they are empty. There's still the test is still not starting, so we are going to start it in the bottom block. As you can see, there is only one test PMD and TRex pods running, and the job is starting. So we are going to see the counters start increasing, the input and output, and we see the same in test PMD. And the next step is we are going to start doing a draining. We are going to cordon the node, and then we are going to empty the node from all its containers. We are picking the worker where the test PMD pod is running, the packet forwarder. As you can see, there is one pod that is terminating and one that is running. There is a new one running. So we should lose access to the pod that was running. And once it gets destroyed, we will get the access to the new one. And you can see it got destroyed, so we lost access to that pod. And also the counters, the input packets, stop increasing. At this point, we are going to try to access that container, but it's no longer available because it was destroyed. And we go to the new pod, the test PMD pod that got created, has a new name. And from there, we are going to well, we are going to check again the packets to see where we are. For the life of this pod, there is nothing has failed because it was just the previous one was destroyed. We are running test PMD here in non-interactive mode, so we can execute past all the configuration. But in our automation, we are running test PMD it has all the configuration. Sorry, I said we are running in interactive mode because we are passing. But in the automation, it's in the non-interactive mode, and we pass all the configuration to the container, so it can start. We can see now that the packets are starting to get there with the new, now that the pod is running. Well, I think it finished. And there, finally, we are going to see the logs of the job, the TRex job, to see how much was the packet lost during the transition of the first pod and the second pod. As you can see, there is a considerable amount of percentage that was lost during the time of the life of those two pods. That's the percentage that was lost. This is the output of sorry. This is the output of a different job, just as a recap, not the job that we saw in the demo. In here, we show it because when we look at the logs at the bottom, in the TRex logs, there is even a negative packet loss. And we struggled for some time to understand what was that. And after some troubleshooting, we understood that it was LDD traffic enabling the switch that was impacting our statistics. In case, I don't know if someone ever see that before. So just to finalize, the conclusions of this work have been that thanks to the automation, the use of resources in Kubernetes, the use of Ansible, we can accelerate the testing of new versions of Kubernetes, new versions of operators. We are not testing specifically the latest DPDK versions, but this is something that we can do in the future. Well, today we have seen how we can use automation to put test PMD and TRex on containers and run them in a platform, a Kubernetes platform. The challenges, well, the first one is that, as I showed you in the demo, we run to do certain things. We need to do interactive mode, but during the automation, we require to do that in non-interactive mode, and that's part of that we would like to address in the future. How? Yesterday we saw a great presentation from Robin and David about Grout. We are talking with them to implement, to try to replace test PMD and start using Grout. Why? Because it will allow us to be able to do more configuration without having to do this back and forth in interactive, not interactive mode. And we also believe that it will allow us to expand our testing. As I said today, as you saw in the demo, it's just a basic packet generation and packet forwarding. But if we can do more, then we can increase the number of tests that we will probably be doing with a vendor CNF. Yes, that's pretty much it. Some links for you for every project that we use during the automation. And I thank you again for your time. And any questions, I'm open to our opinions, suggestions. Thanks.
So, to answer to your comments about UPF, in my company, we have released a UPF kind of solutions that you can start using if you want with Kubernetes. So be welcome. At least we have it in production.
Is that open source? Or?
Yes, on GitHub. So feel free. My second comment is that I don't understand how you use, because for me it's something which is achieved by a Linux Foundation project which is named Silva, that was presented last week in Wien. Mm-hmm. So I don't understand your presentations compared to Silva's. So what are the differences?
What was the name of the?
Silva, SYLVA, which is Linux Foundation's CNF test framework and certificate framework for CNF, for us, for telco providers. So we can validate the Nokia, the Ericssons, and name whatever you want.
Okay, yeah, thanks. I wasn't aware of that project, but ours is just, Example-cnf is just you're trying to use a CNF without any vendor?
Yes, that's the purpose of Silva. I mean, they can use test PMD, TRex, and open source ones. Okay.
Well, in our case, this has been, the project was started like, I think 4 years ago. And I don't know if at that time there was already something?
No, Silva was started like something like 2 years ago, maybe.
Okay. But something that, like I said, we are starting to get familiar with DPDK. That's the reason why we start to get to know more, and maybe it's something that we can start using, like route of that new project. I would consider and bring it to my team.
Yeah, because yes, I mean, I understand the test framework. So then we bring any CNF, route, test PMD, TRex, or whatever. So it'd be good to, at least for the next presentations, next BK summits, to understand the synergies between your work and what is done on Silva, because frankly, here I see a fragmentation of both activities.
Yes, yeah, definitely. Like I'm expecting next DPDK summit, we will have something, Example-cnf with route, but now that you are making this reference, I'll make sure that we talk about that.
Yeah, I'd like to understand which one should we use. Okay, thank you.
Thanks.
Hey, so I think there's a whole lot of things you may have skipped over that are there. I believe under the hood you're probably using Multus.
We use Multus, yes.
And that was never covered or explained. You probably have to use node selectors in order to target specific, to keep TRex and that on specific nodes and things like that. So there was a lot of steering. We never saw any of the configuration files.
Yeah, I didn't mention it, but we don't have node selectors, but what we do is we have a group of workers, our performance profile applied to those workers, and when we deploy Example-cnf, the pods are expecting to find workers that only match those workers.
All right, so that would mean that you have device plugins for the SR-IOV so that they're discovered. Exactly. Okay, that makes sense. Yeah. Are you using guaranteed QoS because you're using DPDK and they have to go hand in hand usually?
Yes.
And most people aren't aware of what that means. You showed in your diagram that you had essentially point-to-point connections between the extra non-CNI network devices. You didn't have a switch there. So as you skipped over all, you have to have some sort of IP management and other things in order for that to just work.
Yeah, we don't have a diagram with that level, but
okay.
Yes, definitely.
All right.
I skip some of the.
Okay. Yeah. Yeah. All right. Thanks.